Independence of variables. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed. Learning objective. Examine independence of variables within a dataset.
We've seen this table before.
You got a good memory, Lisa. Remember the census data we talked about during week 2?
That was SFB1. Something about people and salaries?
Just whether it is over $50,000 or under. I'm looking at how these numbers are split between the genders.
These folks make below $50K dollars, right?
Yes, and we'll investigate some trends. Welcome back to Statistics for Business 1. I'm Shankar and this is Lisa.
I'm an independent consultant.
Our analysis shall be based on a census data set that we've downloaded from the UC Irvine Machine Learning Repository. If you recall, we had cleaned up this data set, so our analysis sheet had a little over 30,000 rows. Here's a small test for all of you. Can you construct this table that I'm seeing on your own?
You mean independently?
Take just a couple of minutes off and try it. Suppose our data set represents an organization's workforce. What can we then say about the male-female split among those making under 50K? Simply looking at these numbers can confuse us. It makes more sense if we can talk proportions.
Wait, I can spot a switch in the black column.
You mean this, Lisa? Smart observation. What I'm going to do is to look at proportions. So I'll copy some of these things over and paste it. What I'll do is to replace this number by its column-wise proportion. So I have 96 divided by 252. I'll keep that part constant, of course, and I will drag it across and then down. Now look closely at the proportions. For now, let's deselect the black in the race column header. So in this, I'm going to deselect black or African American, and I need to take care of the column headers here which have not changed. So I'll bring all else over to the left hand side and clear these cells. We get a new table where it's easy to spot a pattern.
They all stay close to the 3664 divide on the margin.
So knowing that a person making under $50,000 is female won't give us any additional clues as to what race she belongs. Of course, this is specific to our data set. Technically, we say that gender, which is over here, is independent of race in this under 50K data set. The prior probability of a female making less than 50K is, as you can see, 36%. And this is not significantly affected if you impose an additional condition such as the female is white.
Nah, look at the other category. That's a 40-60 split.
Yes, Lisa, but in reality, we will not witness an identical split across the races. We must have some tolerance here, but also know when our numbers have crossed a limit. The idea is quite simple. Suppose we were supplied only the aggregate margin values over here and we had to guess the expected counts in the middle. Now we can see that the expected count in this very first cell here is nothing but 252 times 7355 divided by 20202. Let's go ahead and do that. I get this is equal to 252, where I have to keep the row constant, times 7355, where I have to keep the column constant, divided by 20202, where I have to keep both constant, and I get 91.74 or nearly 92.
Not so far from 96. I'll take that.
Now what I'll do is to populate the rest of the cells and make sure to truncate. So it's a number with no decimals in it. Right. Continuing this way, we get a second table of counts that are predicted by the independence condition.
Wow, they're so close.
And to quantify this closeness, we have what is called the chi-squared test of independence.